Okay, equivalent trig with a cofunction formula. So here are cofunction formulas, and this is our question. Okay, the question says, given that sine pi over 6 is equal to a half, show that cos pi over 3 is equal to a half. So let's actually build a very long expression here. Let's say that sine pi over 6 is equal to 1 half, which is equal to cos pi over 3. Okay, so all three of these things are equal. And what that means is the things on the farthest outsides too, they are equal too. We really don't need this value in the middle. It'd be the same concept of me saying, oh, 5 is equal to 2 plus 3, which is also equal to 7 minus 2. Yeah, that's true. I could pair up any two of these, right? Or maybe this pair, or maybe this guy and this guy, and they're all true when we set them equal to each other. So the half part here is unimportant to us. We can kind of drop that off, and now we're just going to work with sine pi over 6 is equal to cos pi over 3. Okay, now we need to prove this idea. That's what this whole thing is. When they say show that, they mean you have to prove this to me. Prove that these things are equal. Well, what we're going to look for is we're going to look in our cofunction formulas for a relationship between sine and cos. This one has a relationship with sine and cos, and this one has a relationship with sine and cos. We have to decide which way we're going to prove it. And we can technically prove it both ways. Let's see how we can split these. The first one here, what it's stating is that pi over 2 minus some theta value will be equal to cos theta. So let's prove it using this one, and then I'll prove it using this one, showing you that there's many ways to do this. So if we use that first one, this is what we're going to be working with. Sine, and then we have the bracket. The bracket says that pi over 2 minus the unknown, okay, is equal to cos the unknown, okay? The unknown being our theta. Well, when we look at above, okay, they've given us a value for the theta. According to this information, this theta, okay, should be pi over 3, okay, according to the formula we've given here. So if this is true, I'm going to plug in pi over 3 for these two thetas, okay? So we'll change the color just so you can tell it's something a little different. So I just wanted to write the formula first so we knew which formula we're working with. And according to this, it's pi over 3, okay? And that means in this place, according to our formula, this is where pi over 3 should fit. So if this idea is true, what this now means is these two brackets must equate to pi over 6. Okay, so we need to prove this now using our fraction rules. Well, I have 2 and 3, and I need a common denominator. So let's change these common denominators. And because we've now narrowed it down to what we need to do, I don't really need to write the entire expression. I can really just focus on proving that these two things are equal. Because I essentially, the idea is that I split this value here into these two. Let's just make sure that that idea is true. So when I go to do that, I'm going to rewrite this all now in blue. I'm just going to focus on these ideas, or green, sorry. Pi over 6 is equal to pi over 2 subtract pi over 3. Let's find out if this is true. Okay. We want a common denominator, so I'll multiply top and the bottom by 3 here and by 2 over here. Pi over 6 is equal to 3 pi over 6 minus 2 pi over 6. And do these things equate? Yeah, they do. And what you would do is you'd kind of keep following through these two. And this is very similar with trig identities. We're just proving that the left side is equal to the right side here. So we continue with our right side. These two together end up being pi over 6. And are they equal? Yes, they're equal. So we've just verified that the left side equals the right side.
So would it be okay to write it like again, like that step, and then do that?
Yeah, and I would show that on the side. That'd be a great way to write it. What we'll do now is I'll show you using the other identity that it's essentially the same idea. Okay, so this was our other identity. Do I have room? Yeah, let's move everything over just quickly. I'll move all this stuff over just a little so we have some room. Okay, I'll put a line here. So we'll work in a smaller space. Okay, so the other identity, okay, assuming that these things are true again, I'll rewrite the beginning. That's sine pi over 6 is equal to cos pi over 3. Let's use this identity instead. Let's work with this concept. Cos pi over 2 minus theta is equal to sine. So I'll write that same formula out again. Let's do it in blue this time. In this case, there's no adapting the sine side of the equation. It's still sine pi over 6 is equal to cos of pi over 2. And maybe I should have written that as theta, minus theta. Okay? And in our formula, this is the theta. Okay? This is our theta. So this is what our formula says. And according to the information that we have above it, the theta is pi over 6. Okay? So because the theta is pi over 6, that means that this theta must also be pi over 6. So I'm going to plug them in. Let's plug them in and then show that these things are true. This becomes sine pi over 6 is equal to cos pi over 2 minus pi over 6. Okay, so if this is true, okay, I'm just going to show this idea again. Sine pi over 6, nothing's changed here, but something's changed on the right side. This used to be cos pi over 3. Now it's cos bracket pi over 2 minus pi over 6. So we have to prove that pi over 2 minus pi over 6 is equal to pi over 3. So we'll highlight these ideas. We now have to prove just this concept. And we'll do it the same way we did on that. We'll just focus on those things now. So let's do that in black again. Pi over 3 is equal to pi over 2 minus pi over 6. And just like any trig identity, we're going to prove that the left side is equal to the right side. Okay. Let's get some common denominators here. 6 works out great, so multiply that by 2. And this by 3. And this becomes 2 pi over 3 is equal to 3 pi over 2 minus, oh, not over 2. I've done that a couple times now. Over 6 minus pi over 6. And this stays as 2 pi over 3 is equal to, when we subtract that, we get 2 pi over 3. So we've now proved that the left side is equal to the right side. So it didn't matter which of the cofunction formulas or equivalent trig equations we used. We just kind of have to prove that they end up being equal ideas.
Equal to 2 pi over 3 or pi over 3? Something is 2 pi.
3 pi subtract 1 pi would give you 2 pi. Oh, it's not over 3. Oh, silly me. It's over 6. I did that twice there. When I multiplied 3 by 2, you're right. Very good. This should be over 6. And then I changed the denominator. You're right. It's technically pi over 3, but I made a mistake with my denominators here. Sometimes I work way too fast for even myself here. Does that make sense? Yeah. Okay. Thank you for pointing that out. Finish it.